Alright, mathletes, I gotta tell you, it's been kind of an exhausting week. I want to tackle some composite figures with you, for you, but man, I'm exhausted. If I had somebody to help me out, that would be awesome. Somebody like Cedric. Yo, dog, what's up? Hey, you want to help me with some math? No can do, old best friend. I gotta go see my new best friend. Maddie? You know it. She's the bestest best friend I've ever had. Well, she lives in Tanzania. That's right. That's where I'm going. You're going to Tanzania across the ocean because you worked for like a 2-minute video with somebody? I'm pretty sure it was more than 2 minutes. It felt like forever. Alright, Cedric, that just seems like a terrible life choice. You're not going to listen to me. Cedric! No, come back here! Good luck on your trip. I will. That doesn't even make sense. Goofy watermelon, anyway. Alright, well then I guess I'm stuck doing this. Cedric abandoned me. So, drawing of a sailboat is made using a rectangle. Check. See that. And two right triangles. Right triangle, got it. What's the area of the drawing of the sailboat in square centimeters? Now, thankfully, everything here is measured in centimeters, so there's no trick to this question. If they had asked us in square inches, or square meters, or square anything but centimeters, that would be evil. This isn't too evil, it's just kind of annoying. Also, if I cross those two words out, then this sentence still totally makes sense. A drawing of a sailboat was made using a rectangle. Bloop, got it. And a triangle. So the fact that it is two right triangles is nice because it lets us know that this is definitely the height of both triangles. The height always has to be measured at a 90-degree angle. But once we know that, I'd say we don't have two triangles. We're just going to treat this whole thing as one big triangle, because all you have to do to find the area of composite figures is look at each individual shape, find the area of each individual shape, and add the areas of each individual shape. So the area formula for a triangle, and if you don't have your math formula chart with you, you're presumably watching YouTube and not actually taking the test, which is fine. When you do go take the test, you'll be able to look up where it says area, triangle. It's going to tell you A equals 1/2 base times height. So whatever number I find, I'm going to just use half of that number, and I'm going to find it by taking the base, which here is the 2 and the 3 together. The entire bottom line of the triangle is going to be 5, and the height is 6. And then if you could do 5 times 6 in your head, that's golden. You're good. 30, half of that's 15. But remember, the order of multiplication doesn't matter. So if it's easier for you to take half of 6, an even number, and then use that answer, okay, half of 6 is 3, and I don't even need a calculator for that. Like, if I'm confused, I'll use fingers. Keep it, don't keep it. Keep it, don't keep it. Keep it, don't keep it. 1, 2, 3. And then 3 times 15, although if you can't cut 6 in half without your fingers, I'm not 100% sure how you're going to do 5 times 3. I guess you put 3 dots on your paper and be like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That's actually not a bad strategy. Anyway, it's centimeters times centimeters, so it's going to be centimeters squared, which is perfect because I want the area, the entire filled-in part. And then I look down at my rectangle, and on the formula chart, it tells me the area of a rectangle is base times height. So it looks exactly like the triangle, except no cutting it in half at the end. So I just do 12 times 2.5. If you notice, you could get rid of a decimal. You are more than welcome to. Remember, the order of multiplication doesn't matter. And 12 really equals 6 times 2. So 12 times 2.5, especially if you want to do this in your head, which on the STAR test, I don't recommend. But for making math videos, yeah, sure, why not? 2 times 2.5 is 5. So if I do that part first, then the answer is just going to be 6 times 5, which is 30. And I measured in centimeters, multiplied them by each other. And then don't forget at the end, we're going to add those up. So the total area of this sailboat is 45 centimeters squared. And I've got to write it in both colors because I used both colors together. I don't actually have to, but I'm going to because I just did. Whoop. Question number 4 says, a utility line runs underground through Shane's rectangular backyard. Shane is not allowed to dig within 3 feet of the utility line, which is a good, solid idea. Make sure you obey those laws, kids. They're there for your safety. Also, what are you digging in your backyard for? You're a kid. The diagram below shows the dimensions of Shane's backyard in feet. The dashed line represents the utility line. Dash, 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 dash. What's the area in square feet? Again, no trick here. It's all measured in feet. Of the part of the backyard in which Shane is allowed to dig. And so here, we combine the figures using addition. We're going to do the same thing here. We're going to identify the shapes, find the area of the shapes, and then combine the area of the shapes, but we can't use addition here. When I find the area of his entire backyard, the rectangular backyard, I will have found the area of everything everywhere. Which is too big of a number, because he can't dig everywhere. And so I still follow the same steps where I have identified this rectangle here, but now instead of adding that to what I had before, I have to subtract this from what I had before, because this is stuff that he can't dig in. But other than that, the steps are all the same. The area of, and you might have remembered it from the last problem, if not, grab your formula chart again. The area of a rectangle is base times height, which in this rectangle is going to be 22 times 17. Cool mental math trick. 11 times any 2-digit number is just going to be that 2-digit number split apart and added back together. 17, 1 plus 7. So then I just have to do 2 times 8 in my head or on paper, because that would be easier. 14, carry the 1, 16, 17, bloop. The entire ginormous yard is 374 feet squared. And then this rectangle, it's still 17. So when I find the area by multiplying base times height, I still have a 17. But the width of the no dig zone isn't all 22 feet. It's just 6 feet. And I don't know what that is in my head, so I should have written it this way. Boop, 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 boop. That's 42, maybe, I hope. And carry that, and 6 plus that is 102. So I've got 374 minus 102. So I can dig in 4 minus 2 is 2, 7 minus 0 is 7, 3 minus 1 is 2. I can dig in 272 feet squared of Monsieur Shane's backyard. Not me personally. I don't know the guy. That would be rude. But Shane can dig in that much of his backyard. So then there's like a bunch of other shapes that you could do pretty much the same thing with, which is why it'd be nice to have somebody to help. Let's see. I can't call Maddie. She'd be asleep at this time. And apparently she'll be too busy hanging out with a watermelon. Not that I'm bitter. What about that? Oh, Tori? Oh no, Tori's back at the ocean with Finn. Who else has helped me before? Oh, that graduate guy. but I would not ask for his help again if he were the last Lego on Earth. He was such a disappointment. Mr. Krabs took SpongeBob back to the ocean, so that's not an option. I guess I'm kind of stuck with me again, unless King Tut just happens to be walking by. Curse you, ugly bald man. What? I'm not ugly, am I? That was mean. Perhaps mean, but the truth. I'm gonna steal your stuff again. No! Back, foul monster! Yeah, well, Egyptian curses to you, too. Oh, look, I got a frog. That's nice. Frog! Bro, you ate my frog. Oh, sorry. Did you want some? No, but I do want some math help. I did something. Yeah, you did. I remember that now. And the something wasn't much help. I go chase little man now? That sounds like a wonderful idea. You go chase that little man, and I will do math without you. I'm not that tired. Some help is worse than no help. An advertising banner has 4 sections as modeled below. 2 sections are congruent trapezoids. Trapezoids. Yeah, we'll talk about that word here. That's important. And 2 sections are congruent right triangles. Now, that word congruent means that they are exactly, completely, totally identical. So if you find something about one, you found something about the other. Height of one is the height of the other. The area of one is the area of the other. Length, width, shoe size, income, number of front teeth, like literally everything's the same. So I've got trapezoids. Trapezoids are shapes that have 2 parallel sides. They have a single pair of parallel sides. Now, a parallelogram would have all 4 sides parallel to something, right? If this side were parallel, then this and that would be parallel. That's not a trapezoid. A trapezoid looks like it could be a parallelogram if it weren't for that one side that just has to go do its own thing. But it does have a single pair. It does have 2 lines of the 4-sided figure that are parallel. So when it tells me there's 2 sections that are trapezoids, I'm looking for parallel lines. There's nothing parallel to the bottom, so I'm looking, this line going straight up and down, and these 2 lines going straight up and down, those are all parallel. So this is my trapezoid. Zoop, zoop. And I say trapezoid singular because it's basically like I only have one that just shows up twice. Congruent means totally identical. And then congruent right triangles. So again, they're congruent. So if I look at, I'll look at this one because this one has numbers on it. It's a triangle. That part's easy to see. And it's right because, zoop, zoop, it's a right triangle. That's what it tells me. And so that's awesome because then I know that the 2 sides that make the right angle are going to be the base and the height, because height always, for a triangle, has to be measured in perpendicular height. If I try to say, hey, the triangle is this tall, that wouldn't make any sense. It's like if you stood up against a wall and somebody came by to measure your height, and they took the measuring tape and measured this way. I mean, that'd be super good for your basketball stats. You'd look way super much taller than you are. But it would not, unfortunately, be true. No matter how many times I try to get into the NBA. So, what's the best area? Well, if I were me, and I often am, I would say this doesn't look so much like 2 trapezoids and 2 right triangles, as it kind of pretty much just looks like one humongous triangle. So, I think we could just shortcut it and say it's a single triangle, find the area of the triangle. If you doubt me, you are welcome to go back and prove me wrong, but based on this shape being a triangle, I would say we could treat it like a triangle. And so I need, again, check your formula chart if you forgot, the base, I need the height, and then I need to multiply them together and cut it in half. So from here to here is 1 3/4. From here to here is going to be a meter, because remember, these were twins. So from here to here is 2 3/4. 2 3/4. And then I have exactly the same thing over here. So I'm going to have altogether 4 whole and 6/4, but 6/4 is more than a whole. So 4/4 go to make this really 5. I still have 2/4 left over, which is a half. So the base, when I get it all together, is going to be 5 1/2. And I'm not going to write it as 5 1/2, because if I'm going to have to multiply it by a half, then I'm going to want to use it as a improper fraction. So 2 times 5 is 10 plus 1. I've got 11 halves here. All right. Every 2 halves makes a whole. So 2, 4, 6, 8, 10. My 5 whole would be 10 halves. Plus that 1 extra, that's 11. You just multiply these 2 numbers. Zoop, zoop, and add those 2 numbers. And then the height here is going to be, wait a minute, the height of this whole thing is 2. So I'm really not going to have to go back and multiply that by a fraction, because half of 2 is just 1. I only have to multiply this whole thing by 1, and thankfully it's an estimate, so ta-da! Done. Unless somebody emails me and tells me that that was a bad assumption to treat it like a triangle. But it wasn't. Ooh, I guess I could keep going. Landon used a semicircle, a rectangle, and a right triangle, invisible ink. Alright, fine, regular ink, to form the figure shown. What's the best estimate? I'm going to show you some sneaky stuff we can do because of that word estimate. Of the area of the figure in square centimeters. Now, this is all centimeters. Who wants answers in square centimeters? I got some measurements in centimeters already, so no tricks there. And then the steps are all the same, right? Find the area, find the area, find the area. Well, we already dealt with these two. The area of a rectangle is base times height, which in this case equals 6 times 4, which equals 24 centimeters times centimeters. Right triangle is going to be 1/2 base times height. The base here, I got to do some math. If I went all the way from here to here, that was 10. But what if I spent 6 of those 10 just to get to here? Well, then to get the base of the triangle, I just have 4 left. So that's going to be 1/2 of 4, which is 2, if you're going to use that later. And then the height is, well, just the height of the rectangle. So 4 times 4 is 16, half of that is 8. I could have also done half of 4 is 2, times 4 is 8. The wonderful thing about math is it's math, meaning you can do different methods and get the same answer as long as you do it right. And then I got to deal with this circle-ish type thing. Semi means half. Like semi-sweet chocolate is only half sweet. The rest of it's a little grumpy. So half a circle here, it's a little trickier than a whole circle. You'd think, oh, I got less stuff to worry about. Should be easier. It turns out you got to do everything to find the whole area of the circle, and then also cut it in half. So what's the area of a circle? You find it on your formula chart. It should say pi r squared. If it says 11r exclamation point, you probably need to adjust your glasses prescription. Because if you get close enough to that little tiny printy on the formula sheet, it does say pi r squared. And because it's a semicircle, I got to cut it in half. Okay. So I know I need to use pi. And I know your formula chart tells you it's 3.14. But it's not really. pi is 3.14159265, numbers, 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 forever, forever. They say use 3.14 to round, because they don't want you to write forever. They'd probably get sued. And so, if we're going to estimate, why stop at reducing it to 2 decimal places? If you happen to have a multiple choice question, then 9,000 times out of 9,006 times, using the number 3 for pi is going to get you close enough. So, we're going to try it. I'm going to show you how that works. And then r is the radius of the circle, okay? So if this whole entire circle had been here, it would look like our solar system, the big, giant thing in space. And in the center of the solar system would be our sun. The sun radiates, meaning shoots lights out. Shoots light, not lights, not like Christmas lights. The sun radiates outward. Now you'll notice the light doesn't like swing out for a while and then magically come back and go to the other side also. When the sun shoots out the light, it only goes that direction. And so the radius, that's what r stands for, is going to be just from the sun to the edge of the circle. It's only that far. What's cool is, if you went from the sun to the other edge of the circle, it'd be exactly as far. So the radius is always half of the diameter. The diameter is like the distance all the way across the solar system, if you were, by chance, an alien planning a secret invasion. I probably shouldn't have given that away. Earth is closed. Don't come here. But if you know the diameter, and in this case we do, it's the side of the rectangle, you just cut that in half, and you've got your radius. So I'm going to use 3 for pi, and I'm going to use 2 for the radius. And then be very careful with this squared. This is not the number 2 trying to be the number 2. The number 2 would be big, but like this. This 2 wants to be used. Like, hey, write me, use me for math, it'll be great. This 2 is trying to hide. Top secret 2. Meaning you're not actually going to use the number 2 when you see this one. You're going to use whatever the big number is 2 times in a row. And so don't multiply by 2 when you see that top secret 2. Just use whatever number's there and multiply that many times. And I know it's confusing when it is a 2, because you're like, but Mr. Smith, you said don't use a 2 and you just used a 2. Sorry. But if you had like 17 squared, this 2 is top secret, don't use it. You're going to use 17. And the only time you should even know that there was a 2 in the beginning is if you count them. Oh, hey, look, I used that 2 times. But the number 2 doesn't show up in the math because it doesn't want to be noticed. It's a spy. Maybe for those aliens that are coming. Not ideal. Anyway, so I'm going to multiply 2 by itself, and then times 3, and then I got to cut it in half. And so altogether, I'm going to get 3 times 2 times 2, which would be 3 times 4, which would be 12, cut in half. The area of this semicircle is 6 centimeters squared-ish. Right, remember, we didn't find the exact area because we just rounded pi, but it told us we could, so it should be fine. What happens when I add all these up? Well, I've got 6 plus 24 plus 8, and 6 plus 24 is 30, and 30 plus 8 is 38, and guess what one of my answer choices in? Ta-da! So, another math problem taken care of, and another page to go. This is exhausting. If only I had people to help me. Do-do-do-do. Oh, hello there, Muggle. Oh, hello, wizard lady who probably wants to help me. I'm sorry I can't hear you. But you can lip read. We went over this last video. Oh, right. Jolly good. Well, I'm not going to help you. Bye. Wait. Yes? Would you help me if perhaps I mentioned that the last time you were here, I totally lied and gave you the wrong answer for a math problem? Why would that want to make me help you more? Well, because we could go fix it. Oh, don't be ridiculous. All the time turners at the ministry were smashed. There's no way to go back in time. No, I mean, we could just, like, we could... That's cool. Looks like it's all up to me again. The net of a square pyramid and its dimensions are shown in the diagram. What is the total surface area of the pyramid in square feet? Now, surface area is essentially just a composite figure. You could fold this up to make a shape. That's what net means. You could fold it up and make a square pyramid, but when you fold it up, you're not going to paint the inside. So all you have to do is, if you're trying to find the area, just cover every surface that's showing right now, and that's it. So really, I have a square, I have 4 triangles. It's just like any other composite figure. I find the area of each part and add all the areas up. A cool shortcut for a lot of pyramids is that they should be symmetrical. So I could really just find the area of this triangle and double it. And I could find the area of this triangle and double it. But I'm going to be even sneakier than that. Y'all ready for this? I'm going to take this triangle and I'm going to cut it out, and I'm going to put it right here. Slink. So that it's sitting right there. Why would I do that? Well, because if I have to double it anyway, and the triangle formula cuts it in half, it's going to make a lot more sense to my brain to just not double it and cut it in half. I'm going to make a single parallelogram where the formula is just going to be base times height. And then I don't have to worry about cutting it in half because it's a triangle, and then doubling it because there's 2 of them, because I fixed it so there's not 2 of them, there's just 1 of it, a single parallelogram. And I'm going to be super extra sneaky, and I'm going to do the exact same thing over here with this triangle. Cut it out, move it over here, slink, and then I have once again a single parallelogram. Do you have to do it this way? Of course not. Could you do it this way? I don't know. You try it and find out. So I've got area equals base times height, area equals base times height, and for the square in the middle, area also equals base times height. Technically, it is square though, so I know base and height are the same, so I could also say, well, that's just whatever the side is times whatever the side is times itself. That's squared. So no matter how you phrase it, we're going to do 12 times 12. I got 144 feet squared. Oh, good. No trick here. Should have checked for that in the first place. And then I should have written feet instead of centimeters. Feet squared. That's the base of the pyramid, the square. And then for this parallelogram, the base is 12. It's touching the square. It is the side of the square. And then the height is 8. So whatever 8 times 12 is, hope that's right. And then here, the base is still 12. In this case, this side of the pyramid's a little longer. So we got 10. Wait a minute. Oh, those cheaters. That's labeling this side here, which makes sense. A square pyramid should be symmetric in all directions. This line right here is not 10. I tried to trick us. That line right there is the same for all 4 triangles. That line right there is 8. Which gives us another 96. Add those all up, and I've got 6 plus 6 is 12, plus 4 is whatever that is. And then that's whatever that is. And then that's whatever that is. And then I've got this rectangle here that's got like rectangles and rectangles and rectangles. Now, it is a net, which should make it super more exciting, because if you fold it up, you could have a box. But let's face it, I'm a wee little bit exhausted. So it would be super cool if I had somebody to help me. Who else has ever helped with my videos? There was that pilot guy, but he had that weird, annoying droid who told the jokes. I don't got time for jokes, which is also why I wouldn't invite my mother back. Oh, but there were those polar bears. Hey, polar bear dude. Would you like to help me with some math? Da. Russian, right? Wir говорите по-английски? Нет. Well, that doesn't help me. Get out of here. Curse those Russian polar bears. All right, Surfer Dave, I haven't seen since that shark attack. I guess maybe I could find somebody else new to help me. Oh, I hear you're looking for somebody new. Yes, who are you? Oh, I'm a dashing wilderness explorer. Like Indiana Jones? Never heard of the chap. I am Cincinnati... Wait. You're like an Indiana Jones knockoff. I really don't know who this Indiana Jones is. Yeah, right, but you're an explorer, right? Yeah, indubitably. And your first name's a geographical place. Of course. And your last name's probably some garbage throwaway name like Jones. Oh, indeed it is. It's Smith. Brutal. I guess I deserve that. Okay, so your name is Cincinnati Smith. Yes. And you've never heard of Indiana Jones? Yes. Yes, you have heard of him? No. So you said yes, you haven't heard of him. Yes. How do you feel about geometry? Oh, well, I'm more of a wilderness explorer. I like to collect fascinating and interesting animals from jungles and sometimes sewers, but that's not as great. I could imagine that. Well, I'm kind of out of people to help me. I'm thinking back through all the videos I've made. My dad, where's my dad? I'm sure he's busy and grumpy, so I'm not even going to ask him. SpongeBob, my mom, Patrick, Surfer Dave, like the only other people who helped me. Oh no. The only other people who helped me with that video were those people I promised to rescue from the robot army. I have no idea what you're talking about. You don't. Of course you don't. Look, get a YouTube account, watch the videos, catch up. You'll understand it. It'll be great. I gotta go help those people. But what people? By Jove, have you lost your mind? No, look, you and the chameleon hang out, and I'm gonna go rescue some people from the robot army. All right? Deal with the math on your own. I'll be back. Chameleon? What chameleon? Don't understand a word that bald man's talking about. Come back, I have questions!